Yo, what's going on, everyone? Good morning, good afternoon, good evening, good day. We started in 5.3 today, and we're going to kind of move away from the verifying trigonometric functions and identities, and we're going to be solving trig equations now, which are lots of fun. So back to the unit circle. Once you thought that we were done with it, nope. Nope. Don't even try to creep right there, y'all. That will be coming around for this section for show. All right, and so let's go ahead and get cracking here. So what we're trying to do here is we're going to be solving 2 sine of x minus 1 equals 0. And again, solving just like what you learned back in Algebra 1 means find the value of the unknown variable. So we're trying to find x. So 2 times the sine of what? Minus 1 equals 0. All right. So the way that we want to approach these problems here is let's just go ahead and solve for sine of x, because we can't really particularly solve for x. Well, I guess we could use arc sine, but right now let's just go ahead and solve for sine of x. I'm going to add 1 to both sides, so I get 2 sine of x equals 1. Now I'm going to divide by 2, and that gives us 1/2. All right, so sine of what equals 1/2? Now you could, on your calculator, take the sine inverse of both sides, okay, and that's how you get rid of sine, meaning you can do this. You can do the sine inverse of sine of x, right? Because we know that those cancel out, you see, and then you just have x. That means you do sine inverse of 1/2. The only problem with this is that when you do this in your calculator, it's only going to give you one answer, and a lot of times we're going to have more than one answer, which is why we want to be snippety top notch on our unit circle. So for example, if you want to go and put this in real quick, negative sine of 1/2, you would get pi over 6 or 30 degrees, right? But we're going to stay in radians, so you would get pi over 6. But there's actually more than one y value that's pi over 6, right? Because sine of pi over 6 is 1/2, but there's another x value. And let me just show you right here. I actually have a little printout of the unit circle here. So here's pi over 6, but if you look over here, also 5 pi over 6 gives us 1/2. So there's actually 2 answers here. It's pi over 6 and also 5 pi over 6. Okay, so those are the 2 answers. So now it wants us to solve for our trig equation, right? So yes, it's true, pi over 6 you can plug in, and so is 5 pi over 6. However, unit circles just don't stop there, right? Meaning, if I'm at pi over 6, can I add 2 pi, and I'm back at pi over 6, and then add 2 pi again, and then add 2 pi again, and add 2 pi? I can keep adding 2 pi, right? So really, if you look at the way that this is written in here, it's pi over 6 plus 2 pi n. Meaning, if you just keep adding 2 pi, you're going to get all of the infinite solutions where you're going to get 1/2. And the same thing for the 5 pi over 6, you add 2 pi in. So really, our answer should be x equals pi over 6 plus 2 pi n, where n is within the integers. Because if I plug in 1, then that means we'll do 1 full rotation around. If I plug in 2, I'll do 2 rotations, and 3, and so forth. So this gives us all the solutions, and then the other final answer would be 5 pi over 6 plus 2 pi n, where n is within the integers. All right, and so these 2 answers right here would be all of the answers, the infinite answers, because sine goes on forever. And I actually have a graph right here just to show you that. If you look at the sine graph, oops, let me see if I can get this on here. Is this going to work? Yes, it will. Let's see if I can. There you go. Let me just kind of move this down. If we look back at the sine graph, see how right here is pi over 6 and then 5 pi over 6, but then if you do 1 full period again, and then there it is, and it's going to keep repeating itself, see over here as well. So that's why we have to do the plus and minus pi 2 pi.